Hello, I am Naveen Kumar HN, Assistant Professor, Department of ECE, STMIT, Ujre. The topic of today's session is time shift property of Fourier transform. The following textbooks are referred to prepare the presentation. Time shift property. If we know the Fourier transform of a signal x of t, let us consider a time domain signal as x of t. Let its Fourier transform be x of j omega, then we can use like the x of j omega to determine the Fourier transform of shifted signal, means represented in the form of x of t minus t naught. So this is how we can write time shift property for Fourier transform. If x of t and x of j omega are Fourier transform pairs, then x of t minus t naught and e power minus j omega t naught x of j omega are the Fourier transform pairs. Or we can also define it as, if the Fourier transform of x of t is x of j omega, then Fourier transform of x of t minus t naught is e power minus j omega t naught times of x of j omega, where t naught represents the shifting factor. So let us see how we can prove this relation. In order to prove the time shift property for Fourier transform, consider y of t equal to x of t minus t naught. For the time domain signal y of t, its Fourier transform will be y of j omega. We can write down y of j omega as integral t from minus infinity to plus infinity y of t into e power minus j omega t dt. In the integral equation, we can substitute y of t, that y of t is x of t minus t naught. After substituting y of t, the Fourier transform representation y of j omega looks like integral t from minus infinity to plus infinity x of t minus t naught into e power minus j omega t dt. Now in this relation, let us go for a modification, that is, put t minus t naught equal to 2, means replace or modify the variable t by tau by using the relation t minus t naught equal to tau. The integral is expressed for t. Now by substituting this, the integral will be expressed for tau. We have to determine the limits for tau. Substitute the lower limit for t. Lower limit for t is minus infinity. Then will get the lower limit for tau as minus infinity. By substituting upper limit for t, that is infinity, in the form, we will get the upper limit for tau as infinity. Now even we can differentiate this relation by differentiating dt minus 0 equal to d tau. So we can dt equal to d tau. Now the equation can be written as y of j omega equal to integral tau from minus infinity to plus infinity x of tau e power minus j omega times of tau plus t naught. T is replaced by tau plus t naught because we are using this relation t minus t naught equal to tau dt d tau. Now in that complex exponential, we can split the term into e power minus j omega tau and e power minus j omega t naught. The integral is written for tau, so we can keep the functions which depends on tau inside the integral equation, and we can write the functions which are independent of tau outside the integral equation. E power minus j omega t naught is independent of tau, So that can be written outside the integral equation. Now in the integral equation we have integral tau from minus infinity to plus infinity x of tau e power minus j omega tau d2. Now like with respect to the standard relation, only the change is instead of t we have tau here. The variable instead of t it can be alpha, lambda, beta. There is no change at all, because like provided all varies from minus infinity to plus infinity. So like the integral equation wherein we have product of time domain signal and complex sinusoid inside the integral represents a Fourier transform relation. So that is Fourier transform relation for a signal x of x that is represented by function x, so which can be written as x of j omega. So y of j omega can be written as e power minus j omega t naught x of j omega. Now this is the time shifting property of Fourier transform. If Fourier transform of x of t is x of j omega, then Fourier transform of shifted signal in the form x of t minus t naught is e power minus j omega t naught x of j omega, where t naught defines the amount of shift. Now let us consider a problem on time shift property of Fourier transform. The problem statement is, use the time shifting property to find the Fourier transform of x of t equal to e power minus 2t u of t minus 3. To use the time shifting property, first we have to express the input x of t in the form of shifted signal, like x of t equal to shifted form of x1 of t or shifted form of y of t, like that we have to express here. So let us see how that can be done. See, in the input we have exponential e power minus 2t and step function u of t minus 3. Here we have t minus 3. So let us introduce the same t minus 3 that represents shift with respect to exponentials. In order to introduce that, like what we can do here is, like we know that we can like multiplication by 1 is an identity operation. So what we are doing here is we are multiplying x of t by e power 0, where e power 0 is 1. What is e power 0 here? E power 6 minus 6. Now we can write e power 6 minus 6 as e power 6 into e power minus 6. Now I can combine e power minus 2t plus 6. Out of that I can take minus 2 as common, so we can have x of t as e power minus 6 e power minus of t minus of 2 times of t minus 3 u of t minus 3. Now like now we can consider like e power 2 minus 2t into u of t as some signal, say x1 of t. Now let's just look at x of t and x1 of t. We can express x of t as a shifted form of x1 of t, right? Like x1 of t minus 3. What is x1 of t minus 3? Like in replace t by t minus 3 in the equation. So e power minus 2 t minus 3 u of t minus 3. Now like observe, can we write x of t as e power minus 6 times of x1 of t minus 3? Like this is like we are modifying the input here, modifying in the sense like not actually changing the input what we have. So we are representing the input in the form of shifted signal, like x1 of t minus 3. X of t is e power minus 6 into x1 of t minus 3. Now I can use time shift property. How? First determine the Fourier transform of x1 of t, then use time shift property of Fourier transform to determine Fourier transform of x1 of t minus 3, then to that you multiply e power minus 6, by that we will get Fourier transform of signal x of t. Now let us see how to do that. For x1 of t and x1 of j omega are Fourier transform pairs. How can we determine x1 of j omega? Integral t from minus infinity to plus infinity x1 of t into e power minus j omega t dt. Substitute x1 of t. x1 of t is e power minus 2t u of t. After substituting x1 of t, the integral equation looks like this. x1 of j omega is equal to integral t from minus infinity to plus infinity e power minus 2t into u of t times of e power minus j omega t dt. Because of this step function, the limits of the integral can be updated to 0 to infinity, and in the exponentials, like I can take t and minus sign as common, we can write that as the expression can be written as integral 0 to infinity e power minus of 2 plus j omega times of t dt. Now it's of the form integration of e power ax dx, which can be written as e power ax by a, where a is minus of 2 plus j omega and x is t. Now e power ax by a, we have to substitute the limits. The limits are infinity and 0, minus 1 divided by 2 plus j omega e power minus infinity, upper limit minus lower limit, minus e power 0. E power minus infinity is 0, e power 0 is 1. So x1 of j omega is 1 divided by 2 plus j omega. This is the Fourier transform of the signal x1 of t. What is required here? Fourier transform of the signal x of t. What is the relation between x of t and x1 of t? X of t is shifted form of x1 of t. We can write x of t, we have written earlier, x of t equal to e power minus 6 times of x1 of t minus 3. Now let us apply Fourier transform here. Like Fourier transform of x of t is x of j omega. Then Fourier transform of this relation, so e power minus 6 is, it's a constant. What is the Fourier transform of x1 of t minus 3? Use time shifting property here. What is the value of t naught? The value of t naught equal to 3 e power minus j omega t naught. T naught is 3, that into x1 of j omega. What is x1 of j omega? Fourier transform of x1 of t. So we can write the result as x of j omega is e power minus 6 e power minus j3 omega into, what is x1 of j omega? 1 divided by 2 plus j omega. This is how we can use time shifting property to determine the Fourier transform of a signal x of t. Thank you.